Okay, so now for looking at oblique asymptotes. Well, what is an oblique asymptote? An oblique asymptote is a linear asymptote that's on the diagonal. It's not horizontal, it's not vertical, it's diagonal. Okay, so and it would have the form of y equals mx plus b. So to have something like this, so the function tends towards a line as x goes to infinity or negative infinity. So this is end behavior again. Okay, so this is a simple case where the degree of the top polynomial is 1 more than the degree of the bottom. So the degree of the numerator, 1 more than the degree of the denominator. When you divide these two, if this is 1 degree higher than the denominator, then the answer is going to be a linear. For example, if you divide a cubic by a quadratic, you will get a linear answer. If you divide a quintic by a quartic, a degree 5 by a degree 4, you'll get a linear answer. And so the function behaves like those lines as x goes to infinity or negative infinity. So in this case, we're going to look at functions where the degree of the numerator is 1 greater than the denominator, and take a look at the end behavior and what it looks like. So let's jump right into an example here. How about f of x, and we're just going to look at the end behavior for this one because it's not going to be factored. So f of x equals x cubed plus 3x minus 2 maybe, and divide it by a quadratic. So let's do x squared plus x minus 1. I don't know if these factor or not. I don't really care at the moment because I just want to look at the end behavior of a cubic divided by a quadratic. Well, let's do the long division for this and take a look at what happens. So the long division, I'm going to do x squared plus x minus 1 divided into x cubed plus 3x minus 2. Okay, so doing this long division, well, what do you multiply x squared by to get x cubed? We're going to say x. Okay, so x times this whole thing is going to give me x cubed, and then plus x squared, and then minus x. Now we subtract these two polynomials. X cubed minus x cubed is 0. Then we got no x squared term here, so 0 minus x squared is going to be negative x squared. And then 3x minus negative x, those are like terms, so 3x minus negative x is 4x, so plus 4x. And then negative 2 just comes down here. Okay. Now, how do we get rid of the negative x squared? We're going to multiply x squared by negative 1. So minus 1. So we get negative x squared, and then we get minus x and plus 1. Subtract those. Negative 4x minus x minus negative x is going to be 5x, and then minus 3 here, and that's the remainder. Okay, so basically now we can take this information over here and rewrite this function. So rewrite this function. When you divide these two, the answer is, and this is a division statement here really, so the answer is x minus 1. But then we have this remainder. And what do we do with the remainder? We go plus, well, 5x minus 3 over the divisor, which is x squared plus x minus 1. Okay, so if this function equals this, then what happens as x goes to infinity? Well, what we already know is that when the degree of the bottom is bigger than the top, this thing tends to 0. Okay, the horizontal asymptotes of something that just looks like this is the x-axis when the degree of the bottom is bigger than the top. And this will always be the case when we divide these two. Okay, so the bottom will be higher than the top. So, as x goes to plus or minus infinity, this approximately equals x minus 1. So if I go to graph this function and I want to see what's happening at the end, when x gets really large, positive or negative infinity, well, you got a graph like this. We don't know what's happening in the middle at the moment, but at the ends, well, we can graph this oblique asymptote, y equals, okay, so we can just say that implies the oblique asymptote is y equals x minus 1, and we're going to plot that here. So negative 1 is here, say, got a slope of 1, so I'm going to go through it like this and like that, and that's the oblique asymptote. And what we know now is that the function is either going to, out far, is either going to start coming towards it like this on this side or like this. Okay, and on this side it's either going to come like this or like this. And based on the remainder part here, you can kind of tell whether it's going to approach from the top or the bottom, but you'll probably be able to tell that from the information that's in between as well, from the factored form. So for this one, as x gets really large, positive, well, this top part here is going to be positive, and so is the bottom. So it's actually going to approach from the top on this side, because it's going to be x minus 1 plus a little bit, okay, plus a little bit positive. And on the other side, when x is really large, negative, well, the top is negative, and the bottom will be positive. Negative over a positive is going to be a negative, so it's going to be x minus 1 plus a little negative, which is going to be below. So this is what's going to happen over here. Okay, so you can use the remainder to try and determine whether it approaches from the top or the bottom. So let's try one now that, that is factored, and we'll put a couple things into it. So the way to find the oblique asymptote is if the degree of the top is greater than the bottom by 1, you do long division. The answer is this. Okay, so the oblique asymptote is the solution to the long division, y equals x minus 1. You can use the remainder to determine how it approaches the asymptote. And graphing it, well, you want to graph it with the proper points, so there's a 1 there and with a dotted line.